Hello students, in the previous video we implemented a class called integer, and it has a one member that stores an integer, and we performed the different operations on integer. We performed two operations, one is subtraction and one is addition. We implemented add as a member function, and in that we had one implied argument, and the add function added the two integers that were stored in two different integer objects. We also implemented input function and output function for the class integer as well as the constructor. We implemented one more function, that is subtraction. That was a non-member function which was capable of subtracting the two integers stored in two integer objects, but we implemented that as a non-member function. Since it was a non-member function, we saw that it had one more argument in addition to the member function, because non-member functions don't have a object as an implied argument. Now today we are going to implement multiply and division operations of the two integers using the same program. Okay, we'll be first implementing the multiply function of the two integers. Okay, but we'll be implementing it as a class member of the class integer, but we'll be defining it outside the class body. So let us first create a prototype of the multiply. Since it is a member function, it will have only one argument, and one argument will be implied. That is, we will have to pass only one object as an argument. The second argument will be the implied object with which we will be calling this or invoking this function. Note, calling a function or invoking a function is one and the same thing. So we'll call this function as multiply, and it will receive one object, say again 06. Okay, now since we are implementing it outside the class, we have just given the prototype within the class. Okay, this is important because once we implement a function outside the class, we have to give prototype within the class. We'll be copying this and we'll be implementing it outside the class. Okay, so basically we are doing an exercise here. We are doing two things. First, we are showing how to implement a member function outside the class. We have already done the member function within the class. As I told you, we'll be doing the brush up of the topics we have learned in previous videos, and in this video we will again learn how to make a particular class as a friend of a class. We have already implemented what we call friends functions in this example. Now multiplication is a function that we have called as mul. It will be multiplying the two integers. It has got one implied argument and one object as an argument. Again, we have to bind it to the class, so we'll precede the function name with a class name. So precede it with the class name. Again, if I compile, if you see, there is no error. So now we will implement the body of the function. We'll create another object. Okay, let us call that object as answer. Now answer will be storing our results. Okay, answer is a local object created in a member, and as you know, for member functions there is no restrictions. They can access both public, private and protected, all the three parts of the class, because access specifiers only put their effects on the non-member functions. Okay, now integer multiplication is a member function, so I can say answer dot a is equal to 1 is the object with which I am calling, so I won't be using the dot operator here. This I have clarified because the implied object, and then into 06 dot A. Okay, now I will be returning the answer object. So I am returning the answer object. Let us see how this function works. Let us call it. I am first create. I have already done it in the previous exercise. I have created two objects, O1 and O2, and I have input those objects O1 and O2. Now let me add the two objects. Sorry, multiply the two objects. I will be storing the answer in O3. Okay. Then O3 is equal to O1 dot. Since I am calling with O1, so O1 will be the implied argument to multiply function, and I will be passing O2 as a argument. So I am multiplying the two data members of object O1 and O2. Okay, and I will be storing the result in the answer, and the returned answer will be assigned to the O3. We can watch O3 also, so that we can watch the result. O1 and O2 are already added in the watch window previously. So I will watch O3 also. Okay, now I can run the program. First O1, O2 and O3 are created. For O1, default constructor will be called. For O2, I am calling an argument constructor, a parameterized constructor, because the class, in this class I have implemented or overloaded the constructors. One is the default constructor and one is the argument constructor. Argument constructor we have to call explicitly. Default constructor is called implicitly, that is automatically. Again, for O3, a default constructor will be called. So first the constructor is called for O1, then the constructor is called for O2 as well as O3. Okay, now I am inputting the object O1. I have already explained this. Now let the value be 4. Okay, then if you see here in the watch window, O1, the data member A has been initialized to 4. Now in O2 again I will be inputting its member. Okay, let it be -5. Okay, now I am calling the multiply function. Okay, and if you see here in the watch window, that is 4 into -5 is -20. That has been stored in O3. I can equally display the A of O3 by using the member function, that is O3 dot output. Okay, that we have done in the previous exercise, and we have, because we have an output function also here implemented, and we can display that. Okay, now after this I will be implementing the division function of the two integers. Since by dividing two integers we will get a real answer sometimes, so we will be requiring some other class to store that value, because our class has an integer member, so we will be declaring another class called real. Okay, I'll call that class as class real. I have already explained integer by integer, that gives what we call as that gives a integer answer. So we will have to do typecasting, and once we get a answer that cannot be stored in the data member A of the integer, because A has been declared as an integer, since this class implements the integers only. Okay, so I'll be declaring a member in it. Let it be int real. Okay, now let me create a division function within the class as a member of the class in the integer. Okay, I'll call it as a, since this class will, this function that is division will not now return as an integer object of type integer, it will return an object of type real. Okay, I have to, I made a mistake. I have to declare this as a float or double. So I declare this as a float. Now I create the function within the class integer. Okay, I'll be calling it as, let me first define the function, then I'll discuss the return type of the function. I will not write the return type initially. So my function is division. Okay, it's a member of a class, so one of the objects will be the implied objects. Okay, sorry, implied arguments. So I'll be passing integer, second integer, which I'll be dividing with some other integer stored in some other object. Let us again call it as a O6. Okay, now I create here the object of type real. Okay, real say answer, because I have created a class real. Okay, now I will say answer dot real is the member of the real class. Okay, equal to, say that is the first integer a, that is O1, divided by the second integer that is stored in O6 dot a. I have called O1 for a because I'll be calling the function with a, sorry, O1. If you call with whatever object you will be calling the function or invoking a function, that it will be referring to the data member of that object. Okay, now since I am doing integer by integer, you know there's a problem in C. We have already discussed in arithmetic expression, that is integer by integer gives an integer, and we have to typecast one of the values. You can write a float either before the first argument of the division or the second argument of the division. Okay, so we have typecasted one of the arguments, otherwise we would have got a truncated answer, and which we don't want, and the answer will be stored in answer dot real. Okay, now let me compile. There will be an error because we are accessing the private data item of the answer. Let us see first. Okay, so there is an error. Why there is an error? Because a real, that is the RE data member of answer, cannot be accessed in another class. Why? What's the reason? Because the reason is that, let us see that reason also. The reason is that, see here, real is the private member of the class. If we don't declare any access specifier for a class, all the members will be by default private. We'll discuss that. So what is the way out here? We will be making the class integer as a friend of real. Okay, so we can say friend class integer. Okay. So now integer class becomes a friend of the real, and it can access its private and protected part. This is how we will overcome the access specifier rules by using the friends function. Now we have already discussed how to make a particular function as a friend of a class. Now we are discussing how to make a particular class a friend of another class. Okay, now let me compile first. There is no error. So since now integer is a friend of what you call, okay, since integer is now the integer class is now friend of the real class, it can access its what you call private and protected members. In fact, once we make a class as a friend of a particular class, all the member functions of that class can access the what you call private and protected data of that class. Okay, now let us call this what you call division function. So now we'll be calling, instead of mul, we'll be calling division. Okay, division. Okay, now once we are calling a division function, let us display the result, that is O3 dot display. Here we have to make another change also. Sorry, O3 dot output. So we cannot use output here because we have to display the since we are returning a real object from the class, from the division, so we cannot use O3 here. We have to use some other object which is of type answer. Okay, let us create a which is of type real. Let that object be OR. Okay, now instead of storing it in O3, we will have to store it in OR. Okay, let us do it before. Let us see the error that the compiler gives if we don't do it, because that way you will again learn one more thing. Okay. Oh, since I have not declared a return type, which I told you I have to declare it later, that's why the compiler did not report an error in the division. Let me declare the return type as real. Why real? Because I am returning the answer, and I have to write a return statement also. Sorry, return answer. Now the function is complete. Okay, now we'll see what is the error if I call the function. Now I have returned the answer. Answer is of type real, so the return type of the function should be real. Again, I told you the return type should match with the object's data type in which I am assigning. Since the object's data type, that is O3's data type, is integer, but I am returning an object of type what you call real, you will see the error that the compiler will generate. Okay, there is the error. What's the error? Could not find a match of integer with integer real. Okay, so that is why I told you there should be a match between the return type and the value that you are returning from the function and the value in which, or the variable in which you are assigning. So O3 should be of type real. Okay, this is what I meant. Now I'll be using OR. You see the error will be removed. Let us see. Let us compile. Now see here, there is no error. Compatibility between the what you call the return type and the object in which I am assigning the answer. Okay, let us run this program now. Okay. See here, I'll be first inputting the first object, that is the integer. Okay, the first data number of O1, let me call it, let its value be 1. Then I'll be getting the another data number. Okay, A of O2, let it be 2. Okay, so I am dividing 1 by 2. Okay, now after this I am calling a division function, which is a member function of class O1. Since I am calling the function with O1, so O1 is the implied argument, and another argument that is passed is O2. Now in the function, that is, this is a member function. Okay, so I'll be implementing division here. Okay, now I'll be calling the answer. Okay, I'll be storing the result in the answer dot re, that is the member of the class answer. Now since I am doing a divided by OA dot a, that is the two integer variables, that is why I have typecasted. Let us see what the answer is returned. Okay, now since our answer is in OR, let us watch the OR. Now if you see, the OR has the right result, that is 0.5. Okay, if we would have stored the result in the integer objects A, then we would not be able to get the correct answer, because the integers cannot store the floating point numbers, and if we try to assign the floating point numbers to them, then there will be a truncation. So we created a class, another class. So in this exercise we have seen how we implement 4 functions or 4 operations of the integer. One was add, one was subtract, and one was multiply, and one is divide. We have implemented add as a member function. We have implemented subtract as a non-member function, and we have implemented division as a member function, as well as we have implemented multiplication as a member function. Since we implemented sum as a member function, but we defined it, add as a member function, we declared it, defined it within the class, and then I showed at the exercise how we can define a function outside the class. Okay, and how to implement different operations of the integer, as well as input and output function for the class integer. Since this completes our exercise. We can do one more exercise in which we will be implementing the same function as a say suppose add as a member function of some other class. Okay, since we have done as a member function and we have done as a non-member function, but that non-member function did not belong to any of the classes. Since we did for subtract, if you see subtract, that has not been defined in any class. Now let us do one of the operations of the class integer in some other class, and let us try to do that also. Now I have got a class. Okay, say I have got class x, and I will be implementing addition of the integers as a member functions of that class. Okay, now I can implement, I can write public. Okay, I can declare a member function, say add. Okay, I'll be passing two objects to it. One is integer o1 comma integer o2. Since it's a non-member function, the non-member functions of a particular class, say integer, can be of two types. One is those non-member functions which don't belong to any other class, or those non-member functions which belong to some other class. Okay, so add is the non-member function of the class integer, because with respect to the class integer, because add is not defined within the class integer, add has been defined in some other class. Okay, now it returns the integer. Okay, now the same thing we are going to do. We are creating the integer object, say o4, and in o4 we will be storing the result. Okay, o4 dot a is equal to o1 dot a plus o2 dot a. Okay, and then I will be returning the o4, or I can call it as an answer because I have maintained that standard. We can call even this as a o4, no problem, but since I called it as an answer, let me call it as an answer. It hardly matters, but for uniformity sake I am writing this. Then I can say return answer. Then now this function add has been implemented as a member function of some other class, and that class is x. Now since x is a some other class and its member function is trying to access the private data of class integer, that is answer.a or o1.a or o2.a, now it will lead to errors because we cannot access the private members of some other class in the member function of some other class. Okay, let us compile and see if there are errors. Yes, there is error. There is an access error. So how do we overcome this access? We have to make class x as a friend of the class what we call integer. Okay, again we are learning the concepts of friends classes. We can say to the integer that you have another friend, and that friend is a friend class. What's the name of the class? Class is x. Okay, now let me compile again. There won't be any errors. Okay, now let us call the function add. Okay, how do we call it? We now call it as, we first create a object of type of class add. We say class x as the object, say L. Now we can say L dot add is equal to, two arguments, o1 comma o2. Okay, since L dot add is returning the integer answer, so is returning an object of type class integer, so we can assign it an o3. Here we won't be having problems like we had for division. Okay, now let us run this program. Now first I am creating a class, also first object, and I am inputting the first object. Now I have input the first object's value as 2, then as its data members value as 2. Now for second object I am inputting the value as -9. Now O1 and O2, its data members have got the what called values. Now I'll be first, let me first see, okay, here let me first close this window. Okay, now I am calling the add function. Okay, and since add here now belongs to the class X. Okay, now if you see here, the two data members of the two different integer objects have been added, and the answer has been stored in the answer.a. Now answer will be returned, and its value will be stored in O3, because 2 plus -9 is -7. Okay, so O3 is -7 now. Okay, this is how we implement the add as a non-member function of some other class. I'll be using these examples to explain the operator overloading also, so kindly go through this program thoroughly. Now in this program what we have done, we have implemented the 4 operations of the class integer, that is add, subtract, multiply and divide. We have first implemented what you call add operations in the class integer as a member function. Then we implemented division also as a member function. Then we implemented multiply also as a member function, but we defined that outside the class. Okay, then we implemented subtract, but we implemented subtract as a non-member function, and which did not belong to any class. Then we again implemented the add, but we implemented it as a member function of some other class. So these are the different possibilities. You can implement say any operation, say add, it can be implemented as a member function, a non-member function. In a non-member function case, it can be implemented both as a member function of some class or a non-member function which does not belong to any class. We can do that also. Let us implement add in 3 ways, because it will be clear. Then we'll see a difference how we call this add. Okay, you can say integer now, sorry, say add. Okay, since it's a non-member function, it will have 2 what you call arguments. Okay, O1 and O2. Okay, now I'll be implementing the addition, so I can say integer answer. Okay, then I can say answer dot a is equal to answer dot a equal to O1 dot a plus O2 dot a. Okay, then I can say return answer. Okay, now I can call this function. I can get ready. Let me compile it. Compilation, there is error or something. Okay, again we will have a problem, what you call, because add is a non-member function, it cannot access the private data of the class integer. So again we'll have to make it as a friend. Okay, so let us make it as a friend for a particular class. Okay, so we'll copy its first line and declare it as a friend. Now basically I am showing you 3 versions of the add, because that will be helpful for you. Okay, now I declare it as a friend of a class. Okay, teacher. So I prefix a word friend. Okay, then compile again. Is a success. So we can call now. Now if you see, the add has been implemented both as a what you call member function. If you see, there is a add member function, and add has been implemented both as a non-member function. Now in non-member function case, I have implemented add as two versions. One is the add which does not belong to any class, that is this add, and then is the another add which belongs to a particular class. Since non-member functions can belong to any other class, or they can belong to no class. So all the functions that are defined outside the class and are not bound to the class are considered to be the non-member functions of that particular class. Now in this case I am discussing the class integer, so add is a non-member function as well as member function, and in non-member way it is implemented in two methods. One is as a non-member which does not belong to any of the class, and as a non-member which belongs to a class. Now if you see the difference between the member and non-member function, once it is implemented as a member function, it has got only one argument, but as non-member function, whether it belongs to any class or it does not belong to any class, it has got two what you call arguments. This is important thing. Okay, so as a member function we don't because one of the arguments is implied. In case of non-member function, no argument is implied, so both the arguments need to be passed, which are to be suppose two integers which are to be added and are stored in two data members of two different objects. We need to pass both the objects to the non-member function. Now again, there's a difference in the way we are calling these functions. Now if you see in this case that we discussed just before sometime, we are calling the L dot add, but L is the object of class X, because we have implemented this add as a member function of class as X. So we have to call this function as what you call with the object of this class. Now let us see another way of calling, that is the member function, that is O3 is equal to, again we will be calling it with O1 dot add. Now this time I am calling the member function because I am calling it with the O1 dot add. Now I'll be passing only one argument, say O2. Okay, okay, then I am calling again what you call, let me call it with, pass the second argument as O3. Okay, now this is the first call. The first call is different in a way because we are calling with the object of class X. The second call class is different in a way because we are calling a member function, so we are calling with the objects of its own type. Okay, that is, now we are calling a non-member function which does not belong to any class, so it will not be called with any object. So I can say O3 is equal to add of say O3 comma say O1. Okay, now see the difference in three methods of calling. The first call is to a non-member function and we are passing two arguments. The second call is to the member function, and so we are passing only one argument. And third call is again to the non-member function, so we are passing two arguments. Okay, so the difference between, I can write here comments, this has been implemented as non-member function of some other class. In this case class is class X. Now here I am calling a member function. What is the proof of that? Because I am calling that with the object of the same class, so it is a member function. It is a call to the member function of integer class. Okay, now here I am calling again a non-member function that does not belong to any class. So function which does not belong to any any class. What's the proof that it does not belong to any class? First proof is that we are not calling it with the object of any class. Second proof is that it has not been defined within any class. So the operation add can be implemented as a member function or as a non-member function. Once it is implemented as a member function, you have to pass only one argument, and you have to define that function within the class, or you have to define that function outside the class, but using a you have to bind that function to the class by using a scope resolution operator and a class name. Now in case of non-member function, if it is used in some other class, defined in some other class as a non-member function, in that case you have to make that non-member function as a friend if you have declared the data member which you are accessing in that non-member function as a private in the integer. If it's a public member, no problem, it will not lead to errors, but if it's a private or protected, it will lead to errors. So I have implemented now add as member function and as a non-member function. In non-member function I have showed two versions. One is a member of some other class, or a member which does not belong to any class. Okay, now let us call and see what happens. First I am creating the three objects, that is O1, O2 and O3. Okay, now I am inputting the first integer, that is value be 2. Now I am inputting the second integer, let its value be 6, or let us take a negative value minus 9. Okay, now first I am calling a member function of some other class. Okay, add as a member function of some other class, that is X, because L is of type X. Okay, now if you see, the call has been made. Okay, and the two data members have been added. If you see here, you can see in watch window, if you see here, we have got what you call O3 was is minus 7, because O1 was input as 2 and O2 has been input as minus 9. So I am adding what you call O1 and O2. 2 plus minus 9 is always minus 7. So the first call has resulted in the correct answer, that is minus 7. Now there is a second call, and I am calling O1. What's the value of O1? That is 2, and I am passing the argument as O3, that is minus 7, and I am storing the answer in O3, that is 2 plus minus 7, that will be minus 5. Okay, now here if you see, I am calling a member function, so I am calling with the object O1. Okay, and I am passing only one argument. Okay, since add has been implemented as a member function. Okay, if you see here, I am calling a member function, the addition has taken place in the member function. This is a member function add, and if you see now the answer, you are getting a correct answer, that is minus 5 in O3. Now again I am adding O3 and O1, that is minus 5 and 2, the answer will be minus 3, and the answer is stored in O3 as well. Now if you see again, this is a call to a non-member function which does not belong to any class, so we have passed two arguments because we are adding the two integers. So you can understand that in a binary operations, since addition is a binary operations, it involves two arguments. We pass two arguments to a non-member function, but we passed one argument to a member function because one argument is implied. So this you remember that in case of binary operations, and in this case for integers, all the four operations that we have discussed are binary. So if you pass in case of binary operations, you have to, binary means which uses two operands. Okay, since addition operation uses two operands, so since the addition uses two operands, so we have to supply the two operands to the function where we are implementing, then only we can add. But in case of a member function, we have to supply only one argument because other argument is passed by default or it is implied. But in case of non-member functions, we have to pass both the arguments. Okay, now again we are making a call to a non-member function, that is add, and we are adding what you call O3 and O1. So value of O3, if you see in watch window, it is -5 and O1 is 2. Now again the call has been made, and we are now returning from the call, and if you see O3 is what you call -3. Okay, that's correct. So we have implemented add in 3 different ways, and this example I'll be using for operator overloading. You repeat this example, and I hope you can implement the same example for class of type real also, that is addition, subtraction, multiplication and division. And for division you won't be requiring a third class there, because you will have a same data member that is capable of storing the answer, that is RE. Okay, I hope you have liked today's class. Kindly revise it, and it will be useful for the future. Okay, thank you.